Welcome to another edition of The Explainer. Listen, if you are gearing up for the Cambridge Information Technology 9626 exams, consider this your ultimate academic playbook. Today, we are stepping into the dojo to tackle what examiner reports consistently flag as one of the most notoriously tricky, frustrating parts of the entire syllabus, Section 19.1. We are talking about changing opacity and transparency and blending, flattening, and merging layers. I am absolutely thrilled to guide you through this, because frankly, once you understand the hidden structure of what examiners are actually looking for, it's like ancient warrior wisdom meeting modern exam strategy. You can completely transform your approach, slice through these questions with absolute precision, and secure those high-tier marks. We are going to decode the examiner expectations right here, right now, and build a foolproof, battle-tested strategy for exam day. Okay, let's dive into this and look at the roadmap we'll follow to decode those expectations. We're going to start with the misunderstood layers problem, move into the core principles for success, and then lay out the procedural framework. After that, we'll expose the top 3 examiner warnings, outline a deconstruct, solve, evaluate strategy, and finally, focus on securing your method marks. It's a packed session, so stay sharp. Section 1. The misunderstood layers problem. Let's look at why Section 19.1 is notorious for being an absolute bloodbath for lost marks, and why it is absolutely essential that we understand the root cause before we even attempt to solve it. So, I want to pose this direct question to you. Why is Section 19.1 the most misunderstood IT topic? Seriously, why do even the top-tier candidates, the ones who ace every other section, consistently struggle with interpreting complex text and data regarding layer manipulation? Well, the answer lies in a fundamental disconnect between how the subject is usually taught versus how Cambridge actually assesses it. You see, a lot of students treat layer manipulation as just a simple software click. You just lower a slider to change transparency, right? It feels intuitive. But here's the reality check. The exam doesn't just want to know if you can click a button or drag a slider. They are testing your deep understanding of the underlying data relationships and the theoretical architecture behind those visual changes. You have to know what is happening to the pixels, the data size, and the image structure. And this brings us to a massively important point, highlighted by this incredible quote directly from a principal examiner alert. It says, "Method marks can save you." I really need you to internalize this concept. When you are dealing with complex questions about blending or flattening layers, the process of solving the problem, the way you document your mental steps, is just as critical, if not literally more critical, than the final answer you arrive at. Examiners are actively, desperately looking to reward your methodology. If you just jump to the final visual outcome without documenting the logical, technical steps of how you manipulated those layers, you are leaving precious grade-defining marks on the table. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Let's move into Section 2, Core Principles for Success. It is time to lay down the foundational theory that separates average, panicked answers from outstanding strategic ones. Think of me as your elite academic coach for this next part, training you to see the matrix of the exam. It really comes down to a balancing act. On one side, we have theoretical architecture. This is your foundation, relying on precise definitions and causal relationships. You need to know exactly what flattening does to a file's editability versus merging, for instance. On the other side, we have practical application. This is all about integration with other syllabus areas and sharp data interpretation. Principal examiner reports clearly show that candidates who understand how to bridge these two sides, the theory and the practice, score significantly higher. You can't just memorize the precise definition of opacity and expect an A-star. You need to understand its causal relationship when integrating it with a larger data interpretation problem across completely different syllabus topics. It's about showing the examiner you see the whole board. And this brilliantly illustrates exactly what Cambridge is hunting for. Top-performing students exhibit a connected, conceptual understanding that is perfectly transferable to unfamiliar contexts. The syllabus heavily emphasizes that they do not want you to just memorize how to flatten an image in one highly specific software scenario. That's a rigid, weak strategy. Instead, they prioritize analytical depth over superficial breadth. They want to see that you understand the fundamental, unshakable principle of what happens to data when layers are merged. Why? Because if they throw completely unfamiliar context at you in the exam, a scenario you have never seen in a textbook, your structured reasoning remains rock solid. You won't panic, you'll just apply the core principles. Section 3, the procedural framework. Now that we have the mindset and the theory locked down, let's look at the specific, actionable methodologies and professional skills you absolutely must apply when tackling these layer concepts under the pressure of a ticking clock. The examiners have explicitly stated that the presentation of information in Section 19.1 tasks follows very strict conventions. You can't be sloppy here. You must use proper headings. You must use correct terminology. For example, don't write down that you made the picture see-through. That's amateur hour. Write reduced opacity. Use appropriate formats and, crucially, clear annotation. This exact precision is how you demonstrate those elite professional skills the examiners are practically begging to give you points for. Beyond just presentation, your data interpretation skills are absolutely critical here. When you face a layers scenario, you need to follow these 3 discipline steps. First, extract the relevant data from the text and tables provided in the prompt. Don't skim, extract. Second, interpret the relationships. Ask yourself, how does changing the blend mode of this top layer mathematically affect the data of the layer beneath it? And third, draw evidence-based conclusions. You don't guess. You evaluate performance logically and systematically, step by step. Stop scrolling. Subscribe to our YouTube channel AC Exams at acexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, we are moving into Section 4, Top 3 Examiner Warnings. Pay close attention, because this is an exclusive look behind the curtain. We are looking at the exact pitfalls and traps where brilliant students consistently drop marks, pulled straight from the principal examiner reports. Now, what's really interesting, and honestly a bit tragic about this slide, is how completely avoidable these errors are once you're aware of them. The top 3 mistakes candidates make are: number 1, confusing cause and effect; number 2, forgetting to check the format and presentation conventions that we literally just talked about; and number 3, providing generic, copy-pasted textbook answers that are not specific to the unique context given in the exam question. Let's zero in on that first trap, because it is by far the most dangerous trap on the battlefield. Examiners report that students repeatedly confuse cause and effect when dealing with changing opacity, transparency, or when blending, flattening, and merging layers. So what does this actually mean for you? It means candidates mix up the visual result, the effect, with the technical software action, the cause. If a Cambridge question asks how a specific visual effect was achieved, you absolutely cannot just describe what it looks like. You must articulate the causal relationship of the technical steps taken. Did you alter the specific opacity percentage? Did you utilize a distinct blend mode to mix pixel values? You have to explain the cause that created the effect. Section 5. Deconstruct, solve, evaluate. This right here is the master strategy. This is the definitive exam day methodology that top-scoring candidates use to guarantee logical, structured reasoning and seamlessly avoid those exact traps we just discussed. When you are sitting in that exam hall and you are faced with a complex 19.1 question, I want you to take a breath and execute this 5-step problem-solving framework. Step 1, identify the given information and ruthlessly extract the relevant data. Step 2, break the problem down into logical, bite-sized steps. Step 3, solve it systematically using your selected analytical framework. Step 4, check your answer for reasonableness. Step back and ask, does my technical explanation actually produce the visual result described in the paper? And Step 5, make justified recommendations based purely on the evidence. Now, exam pressure is real, so I want to give you a quick, actionable memory hack to help you recall the precise terminology when the clock is ticking. Just remember the letters O, T, B, F, M: opacity, transparency, blend, flatten, merge. I want you to literally write this acronym at the top of your rough paper the second you see a layers question. OTBFM. It serves as an anchor. It will force you to pause and consciously select the exact correct technical terminology rather than panicking and using vague, unscientific language that is guaranteed to cost you marks. Section 6. Securing your method marks. We need to talk about your safety net. This is how you guarantee you're picking up marks even if your final practical execution goes completely off the rails or you run out of time. Listen, top-tier candidates don't just solve problems like robots. They actively demonstrate evaluative thinking. As you write out your steps, you should be subtly showing the examiner your thought process. Question assumptions. Consider different perspectives on how a layer could be manipulated. And above all, justify your decisions with evidence. If you choose to merge layers rather than just group them, tell the examiner why. Explain the technical reasoning, like reducing file size while maintaining the relationship of those specific elements. Demonstrating this high level of evaluative thinking is the secret sauce. It is exactly what elevates an average, passing paper into the highest possible grade boundaries. I want to bring back this golden rule from the examiner's playbook one more time because it's that important. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. The crucial takeaway here is that clear notation is your ultimate shield. Execute your answers with clear, deliberate annotation. Document every single step of your deconstruct, solve, and evaluate process. Why? Because if you make a minor software assumption error or a miscalculation right at the very end, the examiners will still award you massive points for a flawless, well-documented methodology leading up to it. So, I want to leave you with this final, provocative thought to take into your next study session. Are you actively showing your work and building a conceptual understanding to secure every possible method mark? Next time you sit down with a past paper, don't just aim for the right final image. Apply this structured OTBFM methodology. Show your working, use precise terminology, and write out your analytical steps. Master the process, and you will master the exam. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder: subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.